Afternoon, everybody. It's Mr. Williams again, and I'm here with a little mini lesson. This time I'm going to be talking about naming and writing formulas for acids, specifically inorganic acids, because remember, there are a couple of different types of acids. Once again, as we did with ionic compounds, it is extremely important that you know the ions, both their charges and their formulas from your ion sheet to be able to do this successfully. Now, when it comes to an acid, as I said, there's two different types. There's inorganic and there's organic. The key with an inorganic acid is that the formula will begin with hydrogen. All right? It has to start with that in the beginning of the formula. For example, HCl starts with hydrogen. You'll name it as an acid. Remember, they won't be acids really, though, until they are actually dissolved in water. Organic acids, on the other hand, they're also known as carboxylic acids. They will have what we call as the COO group, the COOH group at the end. Like you see here in this version of acetic acid, how it is written as CH3COOH. As soon as you see that, you know it's going to be a carboxylic acid or an organic acid. We're going to focus this video only on writing the formulas for the inorganic kind. Just I wanted you to be aware of them. So, when it comes to writing those formulas, this chart becomes extremely important. If you figure out what the anion is, because remember, since all of their compounds will start with hydrogen, it is important that you identify what the anion's name would be. If the anion's name happens to end in IDE, then you're going to use the word hydro, the root of the anion itself, followed by the suffix ic with the word acid. If by chance the anion ends in ATE, now you're just going to use the root word of the anion followed by IC to replace it with the word acid. And if it ends in ITE, you then have to use the root word followed by OUS. So if you can identify what that anion happens to be, you'll be very successful in naming acids because you know their formulas all start with H. So let's look at the first one, HF. There's only two elements, so just like in ionic compounds, we know it would end in IDE. This happens to be the ion fluoride. And so if this is fluoride, IDE makes it hydrofluoric acid. Again, hydrofluoric acid. We identified it as an IDE ending, and then we do the replacement with our chart. And the next one starts with H, it's an acid, but NO3 is nitrate. And so if we're looking at nitrate, it becomes nitric acid. Very simple. Again, similar ending, but without the prefix hydro, you can tell the difference between them. The last example, well, if we think about it, starts with H, it must be an acid. Doesn't matter how many H's there are. In this case, it's H2SO3. The reason there are two is that hopefully it will equal 0 with the anion itself to make it a neutral compound. SO3 happens to be sulfite. Sulfite, yes, ITE. Now, for sulfite, we will use the root word plus the ending OUS. And this one becomes sulfurous acid. Any acid that has sulfur or phosphorus in it, instead of sounding very quick, like, because that was the sulfite, it's not sulfus acid, we add that extra UR back into its name, and it makes it sound a little more elegant. So this would be considered sulfurous acid. And you'd have phosphoric or phosphorus acid if it would have phosphorus in instead. So those two you got to be a little careful with by adding in that little extra portion of their name in the root word. But that's how we name acids. We first identify them with a hydrogen, name the anion, and then we determine whatever the ending would be of that anion, we have to use it to create the name for the acid itself. What happens if you want to go the other way? Let's say you have the name. Now we got to write the formula. This is very similar to writing the formulas of ionic compounds. We have to first identify the anion. And whatever the anion is, whatever its charge would be, since hydrogen is a +1 ion, the charge of the anion will be the number of hydrogens we need. Example, hydrochloric acid. Since it has hydro and ic, we know that it comes from chloride, which is a 1 minus ion. Since it's 1 minus, and we know that every acid starts with H, which we know is a 1 plus, here plus 1 minus 1, hydrochloric acid is HCl. The next one is carbonic acid. Carbonic, it doesn't have the hydro prefix in front of it, so this means it came from carbonate. Carbonate is CO3, 2 minus. Since hydrogen is still a 1 plus ion, now since we need a 2 minus and a 2 pluses to make it neutral, the charge of the anion, that numeric charge, is the number of hydrogens needed, H2CO3. Finally, we have phosphorus acid. As you see in that name, we had to add that extra syllable back into it because the ion's name is phosphite with that ending, which is PO3, 3 minus. Again, hydrogen is still 1 plus. Since it's an acid, we know it's an acid because the name has acid in it. We have to start it with H. And so therefore, we're going to get H3PO3 for a possible name or a formula for that acid. Hopefully this helps. Again, when you see the names, since they have the word acid, you know it starts with hydrogen. Use the anion to help determine the number of them, and you fill out the rest of the formula. I wish you luck with this. Here are some practice problems again. So I'd like you to try these practice problems, and in a couple of seconds I will put up the answers. So give each one a shot, name the first ones, write the formulas for the second ones, and let's see how you did. Thanks for joining me. Have a great day.